Hey everyone, welcome back. We're here with the second video we'll be doing with Greg. First things first, Greg, how are you?
Very well, thank you, Jason.
Good, good. So cool. Well, to give people a little taste of what we're going to be going over, some of that water testing technology you were chatting about last week, really doing a full video on that, potential use cases, where the tech could be used, obviously, and more in detail just about what it is. Do we want to start off with, do you guys have a name for it other than the water testing tech that I just called it? What are you guys calling it?
Well, we call it our water-based epidemiology application. So it's not much better. We're rushing to try and sign up partners as quickly as we possibly can, and with the goal to try and get it in as many places as we possibly can before the fall. So not much has gone into marketing collateral and those types of things. I guess you could say that we're a product-centric company. So sometimes the marketing suffers at the expense of trying to create new and innovative things and get them out quickly. We also have another product that we call our flood forecasting tool. So it's not very sexy. Yeah. But they're pretty utilitarian tools, and they're directed towards civil engineers and people that really don't like a lot of gimmicky things anyway.
Yeah.
So, yeah.
Well, cool. Do we want to give people, if this is the first time hearing about it, do you want to give the super, kind of 3,000-foot view of what it is?
Sure. That particular tool is we thought about it when we when the whole COVID thing hit, and we thought we immediately, since we dealt with wastewater disposal and stormwater disposal and infrastructure systems and those types of things, we kind of scratched our head, and we immediately wondered if there was some application. We're not experts in the field, obviously, and but there was a study that happened in the Netherlands several months ago, right around the beginning of the breakout of the pandemic in Europe. And the study was very interesting because researchers had discovered that they could identify signals of the virus in wastewater collection samples. And then we immediately thought, that's interesting, and we moved into looking at it a little bit more. We found out that a lot of other work had actually been done in this area previously with SARS, H1N1, those types of potential pandemics that never really hit us the way that COVID-19 has. And so, we also looked into other applications of using wastewater to test on the health of a particular population. What we found was there was a lot of cases where people had introduced this theory, and in particular, a lot of work had been done down in Arizona by one of the universities down there, and a group to identify opioid abuse in different populations, and the purpose of that was to try and gauge to which degree which communities were actually affected by the opioid epidemics, so sort of fentanyl and those types of things that have really high mortality rates, and they're a real problem. And so the two of them kind of merged, and we found out that yes, it can be done. We can get the signals, and where we found a good spot for us to fit into this picture is that we're collecting a lot of the data and a lot of the signals and the information already from a lot of North American cities that are critical to actually coming up with giving an accurate scope of the actual problem within the population. Whereas you might be able to find the signal, like a certain substance or virus, whatever the case is present. What you don't know right off the bat is the extent to which it's present. So how how rampant it is, or how predominant it is within a particular population. And that's where we can come in, because we have all sorts of tools that do things like examine the length of time it takes flow to get from one section of the infrastructure to the other, the temperatures that may affect the samples, the infiltration of groundwaters and precipitation that may dilute the samples to give them a different calculations in terms of the intensity of the outbreak. So these are all things that we can contribute. Plus, we provide a very robust platform with a lot of analytics tools built into it that can be shared and used across multiple different organizations and really communities or scientific communities around the world. If the data wants to be shared and insights want to be looked at. So we thought we had a pretty good place and pretty good tool that, or pretty a reasonable way of introducing our product into this, and that's what we're doing right now. So we're testing it out. So we're looking at samples. We have some people that we're working with, some universities that we're working with, and we're basically perfecting the process, and with the help of academics and health authorities and of course cities and city engineering, we hope to really get ahead of this. And the great thing about this way of testing is that it gives you a window into what's going to happen, right? So almost a prediction, because you can tell up to 7 days in advance really what's going to be happening with the health services in 7 days. So as opposed to just people showing up at the hospital sick, we if the system is in place, we should be able to tell the health services people that, look, there's going to be a problem in 7 days. The indicators are such that you're going to be hit with a problem, and that gives them some lead time to prepare. And
Kind of
so
like weather forecasting.
yeah, weather forecasting with a little bit of a deadly tinge to it. But it's I think it's new, obviously, but I think my opinion is that it's just too good a technology to pass up, and given the fact of what we've been through and what we're going to go through throughout the course of this pandemic, I find it difficult to believe that all significant populations won't have something like this in place in the not too distant future. We're actually talking to and being approached by even mining organizations and remote facilities that aren't cities to investigate whether this is something that they can put in place to protect their employees. And so we're hearing about outbreaks at relatively remote and isolated plants and mines and things like that, and that's a real problem. So there's our focus is on cities, obviously for now, but we hope to, like I said, have as many implementations by the fall as well, when this thing is due to hit us concurrently with the flu season, which is going to tax health services even more.
Really, you've got this system that you put in at the wastewater treatment plant or wherever it'll be, and it can tell you, hey, this virus is being seen. It's, growing as, to the next week, it's increasing or it's decreasing. And that can give, obviously, that city or that population kind of the data they need to act on it. And you can obviously.
There's one more aspect of that as well, is that we don't have to limit the sampling to the endpoint, the sewage treatment plant. We can actually move and start taking the samples upstream to find out where in the system the higher intensities actually are, and from doing this, cities should be able to track down the exact area within the population that things are coming from. So different catchment areas, and then all the way up potentially, to the individual sort of block or neighborhood area. And these are things, of course, baby steps. We can't introduce it all at once, but they hold a lot of promise because with all the information about the infrastructure in our systems already, we're able to make those calculations and help people make an accurate prediction and basically trace this thing up to hopefully where the source of the outbreak actually is.
Yeah, you could, section it off districts and things. And I think that's cool to think about. If you've got a city with, 12 areas, you can have, one tester in each area, and you can say, oh, whatever area 10 is looking like it's going to be, hit pretty hard with this. And we can obviously do prevention measures where if you're going to be locking down a place, you don't have to lock down the whole city. You can lock down that area.
Yeah, when you start to think about cities like Los Angeles and the economic impact of closing down an entire city just because what's happening, if you could try and mitigate the economic disturbances and the social problems associated with lockdowns by just looking at as small a geographic region as you possibly can, that would help as well.
Yeah. So interesting. And I think, again, that's a big picture. Hey, this will make sense wherever there's a, big area, or we can have one of these, readers really, and obviously be gathering information all over the place. So